Hi, this is Toby Kim, and this semester I've worked on developing a modular synth experience in VR with Unity. All the modules I designed can speak to each other in and out at audio rate and can be synced by global clock. I've designed all the models by myself with Blender. I explored new possibilities of visually representing signal flow in VR. Through this project, I want more people to know how fun it is to play with modular synth. To be honest, in real life, their appearance can look intimidating. But making a piece with modules is fun. It's a fun experience. It feels more like you're actually playing with the sound. You're actually interacting with the sounds. So my plan is to build an environment where users can generate their sounds with modules and connect the sound with a visualization system in the game to decorate their own space and do a live music performance there. This project consists of various virtual modules that can be connected and combined to create custom sounds. These modules include a wavetable oscillator, constant number module, multiply module, ADSR module, bytecode filter module, replicator module, and a speaker out module with internal reverb. I've also developed a multi-channel DSP processor with voice allocator and voice combiner that only computes active channels. The wavetable oscillator module is a virtual sound generator that produces a sound wave according to a predefined waveform. It allows users to draw their own waveform with their finger using VR hand controllers, and the input determines the frequency of the sound. The constant number module is a virtual module that allows users to set a constant number which can be passed as an input to other DSP generator. The multiply module and add module take two inputs and output their multiplication and sum total. They are often used to do FM synthesis, ring modulation, or work as a VCA as well. The bytecode filter module applies a bytecode filter to an incoming audio signal. It takes three inputs as one for cutoff frequency, one for incoming audio, and one for Q value. And you can also use your hand to modify frequency and Q value. The replicator module is a virtual module that takes an input signal and outputs three identical copies of it to three different outputs. A common implication of this module is to modify both amplitude and frequency of an oscillator from a same trigger source. To send trigger information, I use snare controller, step sequencer, and keyboard controller. And of course, everything is velocity sensitive. The speaker out module is a virtual module that has an input and an internal reverb. I follow the Schroeder reverb with 4 comb filter and 4 all pass filter with unique coefficients and delay time that I set. It takes the input signal and passes it through the reverb before outputting the final audio signal. Lastly, let me show you how I play with a new type of sequencer that I'm currently working on. All the functionality that I implemented is done in C# Unity. Unity has this basic function called onAudioFilterRead. It gets automatically called when audio source needs to output its data to the speaker. And all I have to do is to fill the buffer with the right data. With that being set up, I was able to write some pure DSP code in C# to do a lot of amazing things. So what's next? Well, I will keep making more modules. I will play this project more to bring the best out of it for the final performance. And thanks to Dr. B, I'm planning on having a master class at the end of the semester so that I can give a speech on this project with more detail. I hope this demo has given you a better understanding of how the system works and how they can be used to create amazing sounds and music. Thank you so much for watching this video, and special thanks to Dr. B and all the professors from EPD for showing me the new possibilities and perceptions that I wouldn't have been able to see it by myself. Thank you.